Okay, in this lecture we're going to be going over continuous probability distributions. Continuous meaning that there are no meaningful gaps. It can literally be any value. For the particular examples that we have today, we're going to be rounding them to whole numbers, but they really can, with a continuous probability distribution, they can be any value and it does not have to be whole numbers. Okay, so we're looking specifically at the uniform probability distribution and how to use it to calculate probabilities if it meets the parameters of being able to use a uniform probability distribution. So a uniform probability distribution is very specific with the requirements. The requirements are that it has to be uniformly distributed, okay? So we've been dealing with normal distributions, binomial distributions, and you have those nice bell-shaped curves. But with a uniform distribution, every value between 2 points should be more or less exactly the same. So you have the mean and the median and the mode, really, that are all the same. The mode really isn't the same, and the reason why is because the mode should be every single value. Every single value occurs more or less the same amount of time. So, but the mean and the median are perfectly centered and are equal. Okay, so and the uniform distribution is completely described by its minimum value, which we label as A, and its maximum value, which we label as B. Okay, and then on the y-axis, you see 1 divided by b minus a gives you the height for the y-axis, or the probability. Okay, so the mean of the distribution, of the uniform distribution, is a plus b. So if you, for instance, are at Walmart and you have a uniform distribution of wait times in checkout lines. And the wait time in checkout lines is between 2 to 7 minutes. So you have, or let's do 2 to 8 minutes. 2 to 8 minutes. 2 plus 8 divided by 2, so 10 divided by 2, gives you a mean of 5. Or if you're looking for a standard deviation, you have 8 minus 2, which is 6, squared, which is 36, divided by 12, which is 3, and then you take the equals square root of 3, and that's 1.73 would be the standard deviation of what I just described. And then, like I said earlier, describing the uniform distribution, you have 1 divided by b minus a. So 1 divided by b minus a, you have 8 minus 2, which is 6. So 1/6 is the probability. So let's calculate that. Equals 1 divided by 6, which is 0.17, is the probability of being within 1 minute, being in one of those 1 minute increments. Okay, so 0 to 1 minutes, you have a 17% chance, it starts at 2. So 2 to 3 minutes, 3 to 4 minutes, 4 to 5 minutes, 5 to 6 minutes, 6 to 7 minutes, and then 7 to 8 minutes. You have a 17% chance of being in any one of those uniform distribution channels. Okay, so let's take a look at this in Excel. Right here, I was downtown Waco, waiting for a trolley with my family, and my sons were getting very impatient, and they're like, "Hey, Daddy, when is the trolley coming?" And the trolley comes every, the trolley is supposed to come every 15 minutes, okay? So let's put 15 minutes right there. and then we're going to determine the mean, the mode, and the standard deviation. Okay, so we have 15 minutes for the max, we have 0 minutes for the minimum, and then we have equals 1 divided by 15 minus 0 equals 0.0667. So equals that. Then we'll just do equals 2 times that, and then equals 3 times that. Okay, and I'm just doing that to show you that it's probability. You really don't have to do these. You really only need this one right here. Okay, so the probability of being within a 1 minute increment, because we're using 1 minute increments, is 0.067 is the probability. So, but let's determine the mean. So we have 15 minus 0 equals 15 minus 0, which is 15 divided by 2, which is 7.5. So the mean is 7.5. Okay. 7.5. And so, so let's determine the standard deviation. Okay. Equals 15 minus a, which is 15. And then we're going to square that. And then we're going to divide that by 12. Okay, 18.8, and then we're going to take equals square root of 18.8 is 4.34 is the standard deviation. And then what if we wanted to find out the number of individuals that wait between 10 to 15 minutes? 10 to 15 minutes. Well, before we do that, we need to determine the area of the probability distribution. So in order to determine the area of the probability distribution, we just need to find out what is the area of this rectangle. So we take equals 15, or the length, or the width, if you will, 15 times 0.067, and that gives you 1. So this right here is the entire probability distribution, which gives you a probability of 1. So if we wanted to find out what about individuals who wait from 10 to 15 minutes? Well, we have 15 minutes on the length right here, but if we're looking at just 10 to 15 minutes, then we've only got 5. Okay, so then we have equals 5 multiplied by 0.067, and we can find out that 0.33 is the probability of an individual waiting 5 minutes for the trolley. Or if we want to find out what is the probability of an individual waiting, let's say, 8 minutes. Okay, so 8 minutes, or 8 minutes or more. Then we would take equals 15 minus 8, so 7. And then you do equals 7 multiplied by 0.067, and the probability of an individual waiting 8 minutes or more for a trolley is 0.47, or so 0.47 is the probability of an individual waiting 8 minutes or more. The math on all of this is really simple, and to be honest, the majority of the applications are for time. And there's really not an easy way to do this in Excel besides just filling in the plots, or filling in the cells like I did here. So if you're going to do a uniform distribution, just do it like this. and you're going to have as good of an effect as any. So the next lecture, we're going to be talking about normal probability distribution, and that will more or less wrap up the entire unit.